Now, I've mentioned this a couple of times, but whenever we compile this code, it compiles it down to something called the EVM, or the Ethereum virtual machine. Don't worry too much about exactly what this means, but essentially the EVM is a standard for how to compile and how to deploy smart contracts to a blockchain. Any blockchain that is EVM compatible, you should be able to deploy Solidity code to. Some examples of EVM compatible blockchains and layer 2s, which again, we're going to go over working with layer 2s more in the future, are going to be Ethereum, Polygon, Arbitrum, Optimism, ZK Sync, and more. Just note that it's important to double check the blockchain before you launch to it. For example, ZK Sync is EVM compatible, but a couple of keywords don't actually work with ZK Sync. Now let's do a quick recap of everything we learned in this lesson. And then after we do this, be certain to take a break, maybe go get some ice cream, go get that extra coffee, or whatever you like to do. The first thing you want to do in any smart contract or Solidity code that you write, be sure to write the version that you want to work with. And above the version, be sure to add the SPDX license identifier. If you're not sure what version to use, for now, just default to MIT. Then you have to create your contract object and name your contract. A contract is similar to a class in other programming languages. Anything inside of the curly brackets for the contract is part of that contract. There are many different types in Solidity, like uint256, string, boolean, int, etc. If we want to create our own type in Solidity, we can use what's called a struct. You can create arrays or lists in Solidity. You can create mappings or dictionaries or hash tables in Solidity, where if you give it a key, it'll spit out the variable associated with that specific key. We can create functions in Solidity that modify the state of the blockchain. We can also create functions in Solidity that don't modify the state of the blockchain. View and pure functions don't modify the state of the blockchain. We can also specify different data locations in our parameters of our functions, but we can only do that for special types like strings, structs, and arrays. Call data and memory mean that that variable is only temporary and will only exist for the duration of the function call. Storage variables are permanent and stay in the contract forever. Function parameters can't be storage variables since they're only going to exist for the duration of the function call. Whenever we hit compile in our smart contracts, it actually compiles our Solidity code down to EVM compatible bytecode or machine readable code. We'll learn more about those specifications later. And last but not least, congratulations on your first contract here.